Well, hello and welcome back. This is Chapter 8, Subnetting IP Networks. Is perhaps one of the most difficult chapter in the course. I will try to do my best, but needless to tell you, there's a really lot more reading need to be done and practice need to be done in order for somebody to really truly understand subnetting. Anyone that is in Cisco will tell you that subnetting is one of the most important and yet most difficult subject in the networking. However, you guys at this level, it's nothing but in introductions. So I will keep it at the level, at your level, and I will also make sure that only cover IPv4. In IPv4, I will only cover Class C to keep it really simple. So I'm hoping that there is quite possible, if there's a demand, I may add another, if there is a request, I may add another chapter where I go into a little bit further details about the subject. But at this level, this is just, again, an introduction like we did in the previous chapter. What we'll cover in this chapter, I'll go over subnetting, implementing an IPv4 address. We're going to talk about what is the subnet and why we subnet, explain how subnetting segment network, and really talk about what if you never segment. If you don't break your network into multiple segments, what will be the consequences of doing so? We're going to explain how process and procedure to calculate IPv4. Though to be honest with you, if you start researching and going to Google and go to YouTube and starting to figure out, trying to find out, you're going to read a little bit more, you're going to find millions of methods out there, and almost every single one of them, it's a bit or more confusing. So that is why I will give you an idea, but I advise you to read and even watch YouTube and find somebody or a method that makes sense to you, but not because not every method out there will really make sense to you. We're going to talk about given a set of requirements for subnetting, how do we implement and how we divide and how we deploy subnetting in any given network. All right, so without further ado, broadcast. Broadcast, probably as you may know, is an important process of networking, but is the enemy of communications. Sometimes, by the way, what is a broadcast? If you remember in the last chapter, we said that network devices can communicate in three major ways. Can communicate in what we call unicast one-to-one, can send messages in unicast one-to-one, can send messages to one-to-many, and usually is known as multicast, or can send messages as one to everyone in a network, and obviously that's what we call broadcasting. Some of the known protocol that use a broadcast, you have ARP, which is Address Resolution Protocol. You have a DHCP, which is Dynamic Host Configuration Protocol. In ARP is when computers know the IP, or the device knows the IP address of a given device, but he needs his MAC address. So I say, hello there. I know your IP address is 192.168.1. That one. I have something for you, but I need your MAC address. This is known. All right, and this will go as a broadcast to every single computer using all FFFF, right? The second time when they will use, and obviously everyone in the network will hear that, and only the computer that IP address will reply, hey, that's me you're looking for, here's my MAC address, please send me whatever you want to send me. Other time when we use, when broadcast is being used, right, heavily, it's in DHCP. When computers start in a network, they go to a process known as DORA process, which is discover, offer, acknowledge, accept, and acknowledge. And this process, in very simple, what happened is when you just start a computer or a device will go into the network and say, hello, guys, I'm new here. I don't have an IP address, and I'm looking for any DHCP in the network. If you do exist, please give an IP address. So, and there'll be a kind of dialogue between the DHCP client and the DHCP server. However, in that dialogue, a great part of it It's a broadcast base. Now, broadcast is, we have to use it. It's a part of our network. But broadcast will become a problem, right? Will become a problem if it increases inside. If you have great deal of devices broadcasting the network, what it's going to do, it may bring your network down. It may slow down your network to the point it may break it down. As a matter of fact, the more computer or devices you have in a given segment, part of your network, the more broadcast will be and the slower that network will be. Now the question, well, how we solve that? Well, we're solving it by, like we said, don't put all your eggs in a single basket. Don't put all your computers in a single subnet or a single network. You want to divide your network into multiple small segments. All right. So watch this example for you here. Is one of the problems. Imagine you have a network and your network is made of 400 users. One single domain. You have 400 workstation or devices in one single network. All right. So what is going to happen is 400 users, obviously they're all going to do DHCP requests. They're all going to do ARP. So there'll be a lot of broadcasting. By the way, look what's behind the router. Okay. There's all switches form a single broadcast. I want you to understand the only device that can break a broadcast is a router. In this case, since we only have switches, all switches are a part of a single broadcast. So as a result, you'll have 400 devices in the same network broadcasting. What is a simple solution to that? A simple solution is reducing the size of the network. And how we do that? You do that by breaking your 400 network into 200 this side and 200 this side, even 200 is a little big. And you have LAN one broadcast this side, one broadcast domain this side, another broadcast domain this side, and a router between them. I repeat again, the only device that has the power to break a broadcast domain is a router. Switch do not have that power. Switch do not have that power. So if you design your network this way, if you create multiple segments for your network will suffer from less broadcast, and as a result, it'll be much faster and much better. And now, doing this, as you're going to see, it is not easy. If you have one single network like 172.16.0, how can you break it down into two different networks? And that's where subnetting comes in handy. All right, here is a reason why you want to subnet. You can see it reduces the overall network traffic and improves network performance, enables an administrator to implement security policies, just as which subnet are allowed or not allowed in certain, to communicate with each other, right? And that's very similar to what we do with when we do with LAN. When we do with the VLAN, you can subnet your network or divide your network into multiple VLANs. And you, for instance, like this one, you have one VLAN for administration, and you have one VLAN for students, and another VLAN for HR, and another VLAN for accounting. And watch that they all have a different network. They are all in different network. The human resources is 10.0.3. The accountant, they're on 10.0.4. And the student on a LAN 2, which is 10.0.2, then you have the administration in 10.0.1. So by doing so, you have broken your network. So what you did, when you do so, you are protecting this LAN or this segment from each other. All right, here's another a really nice example in subnet. Watch how we, instead of making all the entire building a single network, we broke them down into multiple network, LAN 1, 2, 3, and 4. And of course, if you do so, you're going to need to have a router. I repeat again, only a router, since they're different network, only a router can connect what we call a dissimilar network or a different network. In a switch environment, switch cannot do that. Switch cannot, you can't have two networks. One is connected, for instance, let's give it this switch. One is connected to 10.0.2.0 and another one, it's 10.0.1 without having a router. If you do so, those devices will not work. I repeat again. Let's pretend you created a two LAN or 2 segments to VLAN. VLAN 1 over here and VLAN 2 over here. And VLAN 1 is for the HR and VLAN 2 is for the student. VLAN 1 here gets the IP address of 10.0.2.0 and VLAN 1 here get 10.0.1.0 IP address. This device is connected, and here you have a server and here you have a workstation. The server and the workstation will not be able to talk to each other, although they are connected in the same network, to the same switch. And the reason why? Because the switch does not have a power to connect to different network. Only the router can do so. So remember, that's very important. Only router can connect different networks. Well, how you take one single network and you break it down into multiple subnet if you want. Well, before you understand that, what you need to know that the way we have two types of what you call it of IP addresses or network. We have what we call classful IP addresses. They're usually divided at the octet boundary, and we have a classless. Let's talk about the octet at the classful boundary, which is you're probably familiar. You're familiar with. So, for instance, we have, you remember from last lecture, we said we have class A, we have class B, and we have class C. Class A has 8-bit for what we call it, for the network ID, and has 24 bits for the host IDs. Class B has 16-bit for the network ID and another 16 for the host ID. You can watch, I'll do it right here better. Class A, as you see, there are 8 bits are reserved for the network ID, and you have 24-bit are reserved for the host ID. Class B, you have 16-bit are used for the network ID and 16-bit are used for the host ID. You go down to class C, you can see that 24-bit are part of the network ID and only 8-bit are for the host ID. And by the way, I will focus on our subnetting on this class because this is the most common used class in any given network that we segmented. So when we do this, a /8 IP address class A will give you have the prefix of 8 and can give you the number of hosts will give you there's 16 million. Class B gives you 65,000. There's really a lot of waste here and here. Imagine a single network that can have 16 million devices, or a single network that has 65,000 devices. Even a single network that has 254 devices is really a lot. So now the reason why we use subnetting is we're going to break this network into smaller networks. Now you may say, well, how do you do that? And the answer is right here. Subnets are created by borrowing host bit from the network bits. So subnetting will go into, you can see that the net will go into the host over here and we'll borrow some bit and we add it back to the network. All right, that's a borrowing from the host and given to the network. It's very important to remember that in subnetting, you borrow from the host and you give to the networks, right? More host bits you borrow, the more subnet you will create, and more hosts per each subnet you will have. I repeat, the more subnet, for instance, the more bits you borrow from here and you give to here, the more you create. For instance, if you borrow 2 bits, you're going to get 2 to the power of 2, you get 4 network. And you will have 2 to the power of 6 for hosts. If you borrow 3 bits, you have 2 to the power of 3, all right, which is 2 times 2 times 2. You have 8 network, and each 8 network will have 2 to the power of 4 host devices, all right? All right, so here is an example. I'm going to try to go over this example very simply and slowly so you'll understand. So imagine you're given a network of 192.168.1.0, All right, this is the network that you give. So what you have, what we usually use, and you can see, and this is, as you see, this is class C. So this is network ID, network ID, network ID. So how we borrow will come to the host ID, will convert all the host ID to all zeros, to its binary value, it's all zeros, and then we'll borrow 1. All right, you borrow 1. Well, if you borrow 1 to the power of 1, it's 2. Now, by borrowing 1, you have 2 more subnet or 2 new network. All right, those 2 new network that's going to be, all right, those network, you're going to have 192 by borrowing, so you're going to get 192.168.1.0, all right, and you're going to get 192.168.128. So borrowing a single bit will create 2 networks for you, right? All right, so here's another example. By the way, this is videos by Dan, and they are included in your online course. I highly advise you to go because you're gonna need more time. I guarantee you get more time. Now, and they are included in your in the course material in the Netacad. So if you go to your course online, you should see these videos right there. One thing that a lot of people that do when you need to find all the network, they're saying that you need to find a magic number. The magic number is something that they created to simplify this process, which is not usually simple. So here's another example. We have the same class C IP address, 192.168.1.0, all right? And the subnet mask we have over here, in this subnet mask, we borrowed 3 bits. Well, you can see here, we borrowed 3 bits. So if you borrow 3 bits, that means these bits are high bit. This is 128, this is 64, and this is 32. If you add 128 plus 64 plus 32 will give you 224. Hint, that's how we get this to 24. All right, this is the new custom subnet mask if you want. No more 255s. It's only because you didn't take all bits. You only borrow 3 bits from the entire thing. We only borrow 3 bits. So if you borrow 3 bits, you will get 224. Now, it happened to be, what is the magic number according to Dan and a lot of people? The magic number, I call it the last standing bit. The last standing bit. Well, you look at the bit that you borrowed, in this case is 3, and you go to the last one standing before the last bits in the borrowed bit that you borrowed before you hit the zeros is have a special rule. We call it magic. Why it's magic? Because it identifies all the incremental number that you will use to create all your network. By the way, 2 to the power of 3, it's 2 times 2 times 2. Means it's going to give you 8 networks. So to create all those networks, it goes 1, 2, 3, 4, 5, 6, 7, 8. To create that network, you have 2 options. You can use a trick that is called magic number, or you can go and manually do all the math yourself and you'll be there forever. Now, how magically is this? I want you to watch this. So this number, by the way, this is 128, this is 64, and 32. Watch how using this, now we can use a 32 to create all the incremental network that we need. Watch this. We start 0, 32, 64, 96, 128, 160, 192, 124. And all these are incremental of 2. So as soon as you find the magic number, right, magic number, and you know you need 8 network, you're going to go from 0, 1, 2, 3, 4, 5, 6, and 7. And you just keep incremental the number by 32, and you should find all the network that you need. Now watch this. Once you borrow 3 bit, you no more have only 24, 8 and 8 and 8, 24. Now you have 27. Hence, now we have /27. So I repeat again, the magic number, it's nothing science. It's just a method, it's just a technique that we use to find the number, the incremental number that will make it easy for us to find all our network. In this case, you can see here, and it's the last bit in the borrowed bit. in this case is 3-bit, 128, 64, 32. And you can see now the first network is always 0. So you're going to 0 and your incremental number. I'm going to stop here. I'm going to pick up in part 2.